Hello, everybody, and welcome to today's webinar, Build Your Own HiveMQ Extension. We will kick off in a minute, but before we start, I want to give you a quick introduction. So first of all participants are muted. However, you can ask questions during the webinar by clicking on the Q&A box in your control panel. There will also be a 15-minute Q&A after the presentation in which Anja and Georg will try to answer your questions. If we can't answer them all, they will be answered on the HiveMQ community forum. The link to the community forum will be shared with you afterwards. Additionally, we will also start a quick feedback poll during the Q&A session and would be very pleased if you could give feedback on this webinar. And I also want to let you know that this session will be recorded and shared with you afterwards. This is everything you need to know right now, and I guess we can start now. So now I'm happy to introduce you to today's speaker, Anja Hembrecht-Schaar, who is professional service consultant at HiveMQ, and Georg Held, who is HiveMQ software developer. Welcome, Anja and Georg.
Yeah, thanks, Verena. Yeah, well, I will go to the next slide because you introduced us well. So yeah, today we will talk about how to build your own HiveMQ extension. And at first, I would like to explain what is a HiveMQ extension. So when you look up to our HiveMQ ecosystem, maybe you know this, or hopefully you know this, you see HiveMQ is available with different editions, and the extension framework is part of the open source platform. That means you can work with the extension framework also on the open source platform edition. It is part of the open source platform beside the public broker that you also can use, and also our MQTT client library and some other tools. So a HiveMQ extension, yeah, what is this? This is a simply spoken Java program that is using Java 11 and that uses our HiveMQ SDK to interact with the broker. Therefore, we have implemented a community extension SDK that allows you to seamlessly link your own business logic to events, to messages, and content that is processed by HiveMQ. And additional to this SDK, we have also very fine-grained documentation and a lot of examples that are available on our homepage. And you can find the documentation here as described in the link on the bottom of the slide. Oh, sorry. This is sorry, sometimes it's jumping. So again, yes. So what interactions can be done with our HiveMQ message broker? You can use a service API to interact with HiveMQ and the connected MQTT clients. You can also use callbacks that can be registered or are registered and that are called by HiveMQ when a certain event occurs. You can do inspection and manipulate MQTT data, for example, the payload, but also the related data like sessions, like retained messages, subscriptions, and many more. And what is often the case that customer adding authentication and authorization implementations for their MQTT clients. And if you have a very specific cluster set up, you can also add a cluster discovery mechanism by your own. And for sure, you can add your own custom logic to HiveMQ. So the typical use cases are writing messages to a database, integrate the customer's service bus or collecting statistics, and add fine-grained security. Yeah, but now let's go a little bit more into detail how we do extension development. So what tools are needed for this? So for the first, you need a HiveMQ broker, ideally locally installed on your PC. You need Java 11, You need Gradle as a build tool, and yeah, an IDE like IntelliJ or Eclipse would be very nice. Additional to this, we have also our Java docs available. You can find them on the link described here on the bottom of the slide. And yeah, so we will start with setting up our project with Gradle. And this is where I would like to take over, to hand over to Georg, my colleague, because he will show you this in a hands-on session. So
thank you, Anja. Thank you for the introduction. So let's start. As you can see, I have already created an empty Gradle project. So this just contains the settings Gradle and the build Gradle and the folder structure for the eventually the class files, just a normal Gradle setup. And I'm using here the Kotlin variant of Gradle, not the Groovy one, but Groovy is fine as well, of course. First, let's go to our settings Gradle, and you can see we already have named the root project as the database extension. Anja will go into detail on what the extension does that we will develop today together. But the first step needs to be to tell Gradle to use the HiveMQ Gradle extension. So this is what we use to develop HiveMQ extensions. So we first need to tell Gradle that we want to do plugin management. And we want to add one new Gradle plugin. And this is the com.hivemq.extension. And currently there is only the version 1.0 available, so we use that one. Now we have set up plugin management. We need to tell the build script that we want to use this plugin. So we go to the build script. You can see I've filled in the group name and the description and the version, so the standard metadata for Gradle project or Maven projects. And I set up a central repository, just using standard Maven Central, and an empty dependency field. And now we need to tell the build script to use the HiveMQ plugin. And so we do that, just say here, plugins. And then we again use the ID. HiveMQ. And this now allows us, let's wait for the sync, allows us to specify some very important metadata that every HiveMQ extension needs. So we get the HiveMQ extension metadata here. And there are a couple of necessary pieces of data and a couple of optional ones. The first necessary one is the name. We want to add a name here. And we call this the HiveMQ database extension. Then we want to add an author. In this case, me. And we want to add a priority, which is, we want to add a main class, which we need to tell the extension about. So we say main class. And I already set up a main class. You can see it's an empty class. Someone used the imports. And we just get the reference to this and add it to the class so that it can find it. And now we can specify some optional metadata, for example, the priority. This just tells in what order extensions are loaded if they are added at the same time. We can set this to a default value of 1000. And last but not least, the SDK version we want to use. So Anja already showed you the HiveMQ SDK. We need to specify what version we use. The current latest one is 4.4.2, so we will use that. And that's pretty much it. Now we can start using developing the HiveMQ extension. We have the project set up, and I will give back to Anja to continue with the presentation.
No. Yeah, thanks, Georg. So I will shortly recap what we have done here and what Georg showed us. So he showed us that he used our HiveMQ Gradle plugin. And this is the plugin that registers all the basic tasks for you that are needed from start to finish. And yeah, we have to set up this in our Gradle settings file with the newest version. And also we have to define the root project name, which is here the database extension. And in our build file, we have to apply the plugin. And yeah, so and with this, we have all the properties available that we need for our HiveMQ extension, and the properties that we have to set in our build file. So the default properties, group, version, and description, and our specific HiveMQ extension properties, the name, the author, and the main class, which are required properties, and the optional properties, priority, start priority, and the SDK version. And with this, our setup is finished, and we could try out by running the Gradle wrapper with the Gradle task HiveMQ extension zip. And this task will create our structure and a little bit more, what I will show you later. But at first, we will take a look to the project structure. And so when you look into your IDE, you see on the left side, so at least 3 files. One is our main class, the database extension main class, and that is has to be implement our extension main. And these extension main class is there you have to implement or override 2 methods. These are the extension start and the extension stop method. And so with this, HiveMQ knows that, and you can add your custom code to start and stopping your HiveMQ extension. And you have also to add the, or also the HiveMQ extension XML file will be added, and another text file, the com HiveMQ extension SDK API extension main. And this text file is the manifest file that is automatically built from our Gradle task, and it has to point to the main class of our extension. And so now with our Gradle task, this is something that will be automatically done and should be then always right. But if this doesn't fit for whatever reason, the extension could not be loaded. And yeah, the third file I mentioned is this HiveMQ extension XML file. And in this file, all the properties that we set in our Gradle you can find here. And this is also built automatically. And these XML file will be read from HiveMQ to know about the start priorities and all the properties and the extension information. So, but now, let's go back to our extension. And the next question is, what should our extension do? I think you can guess because the name of the extension is database extension, and we decided in our example that we will create a small extension that simply dumps all incoming MQTT messages into a database. And for this, we need 2 major steps. The first thing is connecting to our database when our extension will start. And the second thing is that we have to catch any incoming MQTT publish messages and forward this to our database. So what do we need to do when we want to create a database connection? And in our extension main class, we have to create a database connection by connection pool, for example, in the extension start phase. And to have no garbage, we also have to close these data source when we stop our extension. And how this is done in detail will show Georg in another hands-on session.
Thank you, Anja. So first thing, we are in Java here, and usually for Java you use JDBC. So we will need some dependencies. And I can show you something very nice here, what comes with the HiveMQ Gradle extension. And this is, you have different scopes for your dependencies. So most often you will use the implementation scope, which is stuff that is available at implementation and during runtime. But sometimes you can use something like HiveMQ provided. For example, HiveMQ brings a Logback Classic with it and allows you to implement SLF4J. And so you do not need to additionally bring this dependency with you. So we have this the scope HiveMQ provided, which is something that HiveMQ provides for every extension that uses it. Another thing that is HiveMQ provided, but you do not need to manage it, is the SDK. So HiveMQ will provide this dependency for you. We just made it implicit, but you could, of course, write here HiveMQ provided, HiveMQ SDK, and so on. So let's go to our extension main and implement it. First thing is we need to implement the necessary interface, and the interface is called extension main. So we just do that, and we already see that we need to implement 2 methods, the start and the stop method. So they are not default methods, they need to be implemented. Just make some nice Java here. And what we want to do here is we want to start data source. So I choose to use Hikari, but this is no. So every other could be used as well. So first we need like a small method that sets up our data source. So what do we need for that? I prepared it offhand. So we need to set our config. I just have a local running Postgres here, which I want to connect. Need a password, a username, and some other settings like auto commit, so that it is a little bit more smooth. And that's pretty much it. And we can now call this method in the extension start. And as we want to keep the data source running throughout the whole execution time, so whole runtime of our extension, we just assign it to a field here so that we can use it. Now you can see already something which is perhaps unusual, depends on how you develop in Java, and this is these nullability annotations. The HiveMQ SDK provides them throughout, and what you can use them to create inspections for fields, so that you can avoid a lot of nullability mistakes and nullability errors at implementation time. So if you are like if you use them throughout, usually your IDE can tell you where a field might be null, and you can avoid that by inserting a null check or something like this. But we are not done here. A database data source is, of course, an external connection, and could be a resource leak. So we need to close it at the stop of our extension runtime. So we just implement it here. And that's pretty much it. And before we go on how to use this database connection to store publish messages, Anja will give some more exposition.
Yeah, thanks, Georg. Okay, yeah, so the next thing is how can we run our extension? And because with this piece of code, we should see something in our log file when we run this. So for this, we have another goal. And the simplest way is to run the Gradle wrapper with the goal HiveMQ Extension zip, which creates a zip file with all the stuff that we need for the extension. And then we put the extension zip file into our extension folder from our local HiveMQ instance. And we have simply to unzip the file. And if your HiveMQ is running, then you can take a look on the log files. And if not, you have to start HiveMQ. And if everything is fine, you should see in your log file these both lines where we see that our connection pooling is started. And if everything is fine, then HiveMQ will log the information that our extension with the name that Georg gives the extension, the HiveMQ database extension, is started successful. And yeah, that's fine then. Then we are fine. So, but yeah, so let's take a short look to our extension lifecycle. So every extension has an extension lifecycle, and we have the possibility to handle extensions with hot reload. So that means that our HiveMQ must not restart or shut down and start again if we want to change something on our extension. And yeah, because HiveMQ is looking periodically into the extension folder if there are some news. And for example, an extension will be automatically loaded when it's fresh installed, or if it was if the extension was disabled in the past by a disabled flag and it is removed. And then the extension will be reloaded again. If you want to stop an extension, it is really recommended to do this always by adding the disabled flag at first and maybe later remove this. And an extension can also be stopped programmatically. For example, if you implement in your extension start phase and if in your error handling you're using the prevent from start method, so that if any error occurs during the extension start, the extension will be disabled. In this case, also this disabled flag will be created, and yeah, and the same mechanism is working. So, but maybe we don't want to build always a zip file, and we would like to run our extension from our project. So this is also easy, because we have also prepared a graded task for this, and the task is named prepare HiveMQ. So the first thing is that we use the prepare HiveMQ home property, and here we can set our HiveMQ folder to our local HiveMQ instance. And then when we run the graded task, run HiveMQ with extension, in the background, the HiveMQ will load it from our HiveMQ folder, and our extension will additionally load it, so that that we can run from our IDE and yeah, look if our extension is working. So if this is all perfectly working, then you should see a log statements like here described, and yeah, you can then run your HiveMQ extension from your project, from your IDE directly. So let's go back to our second major step for our extension. So what do we need to forward the MQTT messages into our database? Yeah, we need a way of interaction to be able to get each or some specific incoming published messages. And maybe we also can use an external service that we have no blocking code in our implementation. And maybe if you have something more to do, or you will do it better, then you will also maybe add some metrics about these operations. So there are a lot of things that can be done here, but we will concentrate on the first point. So, but for this, we will take a short look to our interactions, and we will look at the life cycle of each MQTT client. So it starts that we can listen to each MQTT message, starting with connect. We can listen to this event and check. If this is successful, the client can be authenticated and permissions for publish and subscribe can be assigned so that the client is authorized for accessing certain topics to publish and subscribe. We can add here also functionality for authentication and authorization, so that for each and every publish or subscribe that will be sent by the client, we can interfere and do something with the message. And also last but not least, the client can send a disconnect or can be disconnected by the server. And also we can add here functionality via our extension SDK. So the extension SDK supports listening to events, connect, disconnect, authentication, authorization, scheduling, and manipulating messages. We have a lot of interceptors implemented. So available interceptors are, for example, for connect inbound or for connect outbound. We can use a publish inbound interceptor or publish outbound interceptor. We can use disconnects and many more. For our use case, we need the publish inbound interceptor, and this inbound interceptor we must add to a client or a global initializer, and this has to be registered by our registry. And another concept in our SDK is that we have input objects, and input objects are only informational objects. That means that you can only read, and they are quite unique formed. So we have, for example, input objects you have seen for the extension start input or for the connection start input, and also for the publish inbound input. And this is the object that is interesting for us. So the object contains publish packages, package information, it contains client information and connection information. Our publish inbound interceptor performs interception at the moment of receiving an MQTT publish. And you can use this interceptor either to modify inbound publish messages or also to prevent them. So for example, if a delivery of a publish message is prevented, then the message will be dropped. You can also use multiple interceptors, and in this case, they are called sequentially, and all the results will be written into the output object one after each other. And you can also wrap your publish inbound output object into an asynchronous object so that you can work with asynchronous mechanism. So, but now it's Georg's time to show how to intercept an MQTT publish.
Okay, thank you. Before we do that, let's just take a quick look at our database. So I set up a local Postgres database which contains only one table, one relation right now, to store all our publishes. And this table contains the topic of the publish, the publisher, the quality of service, and the payload. And now we want to fill this table, this relation, with all the incoming publishers. Just so no cheating here, this is at the moment empty. Let's go to our IDE. So what do we need? Anya already told us that we need an publish inbound interceptor. So we need to create a class that implements this interface. So we create a new Java class, and we call this database publish interceptor. Looks good. And this class needs to implement the inbound publish inbound interceptor, not the inbound publish interceptor. And again, we just implement the method. It has only one method that needs to be implemented. This is the inbound pub arc interceptor. We need, of course, the publish interceptor. So let's delete the old method here. So this has only one method on inbound publish. These methods get called for every inbound publish that this interceptor applies to. I will show you later how to apply the interceptor to every incoming publish. Just clear it up here. And what we want to do here now is to insert these into a database. So first we need the database connection. So for this, we create a constructor. And this constructor needs to get the database information. So the query data source we created in our extension start class. And with this, we want to do SQL queries. So I will wrap this data source in a query runner. So it's a very nice Apache project with database utils. And this makes it very easy to interact with databases. Again, we want to have this for the whole runtime. So we save it in a field. So what query will we use to insert something? Yeah, pretty basic. I prepared it for us. Can just take a quick look at it. So just want to insert into publishers. This is the relation I created. I showed you before. The topic, the publisher, the quality of service, and the payload. Now, okay, let's do this. And for this, we pretty much just need to get all the information we're interested in. So we take our publish inbound object. And now we can look what is there. We have the publish packet and the client information and some of the connection information. Pretty much everything here is from the publish packet. So in the publish packet, we found all the MQTT information. And the first one is, of course, the topic. So we just saved it in a local variable. And the next one that we get from here is the quality of service. Again, publish inbound input, publish packet, get quality of service. Now, as you can see, this is not an integer. Our database, of course, expects an integer, but this is an enum object. We can just look at it, see the Java docs here, and we can see this has like a method to get the number from it. That's exactly what we need. So we just call this and get QoS number. And again, we save this in a local variable. So next thing we need is the payload. And here we are in a little bit of a pickle because MQTT publish messages require a topic and require a quality of service, but they do not require a payload. So the payload can be null or empty. And we can see that reflected in the publish inbound input. So if we get the publish packet and get payload, if we just assign this to a local variable, we see that this is an optional. And yeah, you will know the Java optional object type. So this symbolizes that this might be not there, and we have to make sure it is there. Additionally, this is a byte buffer, and it's actually a read-only byte buffer, so that you cannot directly interfere with the input object. If you wanted to interfere, you have to use the output object. So what do we want to do? We want to get the payload out from this optional object in a null safe way, and we want to transfer it into a byte array, in a Java byte array, so that we can write it into a database. And for that, I prepared a quick snippet for you. on an efficient way of doing that. So I prepared this small function here. It just maps a byte buffer, tries to read everything that is in the byte buffer and readable, and returns a new byte array. And we can use this now to map our publish payload. So we have the payload, and now we need to map it to get the byte array. So just use the function. And this is still an optional, of course. So if you would assign this, we would get, we can just assign it, we would get an optional of a byte array, but we want to have a byte array. And so we just say this one here. And if you watched before, you have seen that the database does not require the payload object. So the payload can be null. So we just return null if it's not there and write null into the database. Last thing we need is the publisher. And this one we won't get, of course, from the publish object, because the publish object, MQTT publish object, does not contain a publisher. This is information that is that the broker can provide. So what we do is we ask our input object again. We can see here we have the client information, and the client information contains the client ID, which is the publisher in this case. So we assign this one as well, call it publisher. And now we have everything we need to populate our database. And so we want to do that. And of course, we just use the query runner here. That's why we created the object query runner. And then we call an insert and use our query here. And then what we need to do next is to do an result set handler, as this is an insert statement. We are not really interested in the result set. So we just drop the result set, map it to null, and then we need to populate. And the first thing is the topic. So we insert the topic here. The next thing is the publisher. So the publisher, then the quality of service level, and last but not least, the payload. And that's pretty much it. What doesn't my result set handler not like? Of course, there's no result set to handle in here. So we need to handle the result set. So what you can now see is that we have an unhandled exception because the query runner can throw an SQL exception. And now the last thing we need to do before we can test our extension, before we can test this class, we go and use it, is to add some error handling. And here comes into play what I showed you before with the logging. So we can access the HiveMQ logging framework by just simply creating a new logger, an SLF4J logger. And let's just do that real quick. So this is the standard way in Java to create a logger. And now we can do some nice logging here if something goes wrong. So we can say log error, something bad happened. So, and because we want to know what bad happened, we just log the exceptions, of course. So this is everything to store an MQTT message into a database. But we are not entirely done, because we need to tell the extension system that we should apply these database publish interceptor to every incoming publish. And we need to do that in the extension start again. So we go here and access the services. So we have the services class, and we can access here the initializer registry. Set a client initializer. This can be very generic. We just want to initialize for every client the same. So what we actually need is this client context object. And we want just every client to have a new, our database publish interceptor. So we just create the object. give it the data source. And we can set the client context with add publish inbound interceptor, exactly what we want to do, and just add the interceptor. Again, we could do some logging and some error handling here, but just for a quick show how to do that. So let's see if this works. Anya already showed you how to do a run with HiveMQ. So let me just add that to our Gradle. Build Gradle. So we just add a run with HiveMQ. Set debug to false. We don't want to debug right now. And then let's run with HiveMQ. And we can see if I made a mistake. So what can we see? We see that the data pool was started. We see that our HiveMQ database extension was started. This is what we hope to achieve, and that the HiveMQ is running. And now just see if it works. So we just publish a message here. I'm using the MQTT, HiveMQ MQTT client for this. So we publish this, see that no exception was logged, which is good. And we can look at our database and see if we got something. And in fact, we just stored the publish message in our database. That's it for the hands-on demonstration, and I will give back to Anya.
Yeah, thanks, Georg. So maybe you have also the question, how can I debug my extension? And also for this, we have something in our Gradle plugin. And for this, you only have to set in the task run HiveMQ with extension, the debug options, and you only have to enable them. And then you can also add here. So by the way, you can also add here some further configuration files or some other extensions if you want to prepare a very specific setup for your HiveMQ. And then you can start debugging. So directly from the IDE. So here you see that you can add some other extensions. And here, this is how our debugger will be enabled. So when you go then to your IDE, you can just simply add in a new configuration for remote, and then OK. And then you have only to give it a name. And you can all, the standard settings can stay as they are, because this is how it works. And then you can run your new debug configuration, yeah, and just setting a breakpoint before, yeah, so that you can see and that the debugger will stop somewhere in the code of your extension. Yeah, what about testing? So we have also an open source project that is called HiveMQ test containers, and that can be used to do integration tests. And the HiveMQ test container is yeah, responsible for automatically starting HiveMQ Docker containers for JUnit 4 or JUnit 5 tests. And it enables integration testing of custom HiveMQ extensions. Or you can also, if you have your own MQTT client applications, you can also test them with this. And yeah, in summary, so finally, what you see today, we explained what is the HiveMQ Extension SDK, how powerful the SDK is, how easy it is to set up, to run, and how to debug an own extension. But we have also a marketplace, and I will give you a short look into this. So our marketplace is available about our HiveMQ homepage via the extensions page, or you can also go directly to our GitHub repository from HiveMQ, And we have a couple of pre-built extensions that are public and open source available. So this is only these are only some of them. And if you are interested in commercial extensions, you can also take a look. So we have also 3 commercial extensions. One is for bridging, one is an extension for Kafka, and we have also an enterprise security extension that gives you a couple of ways to do authentication and authorization for your MQTT clients. So now we will come to questions, and I will give back to Verena.
All right, there are now 2 open questions here. I will quickly start the poll, so please give us feedback on this webinar. Okay, Jose asks here how to get more details. Is this code available on GitHub?
Anyone take us, or should I?
No, you can.
Okay, so the code for a database extension is right now not on GitHub available. This is like a small example project, but there's a lot of extensions that do very similar things available on GitHub. So you just go to github.com/HiveMQ, and there is a lot of extensions there. Additionally, of course, more information can be gained from the HiveMQ homepage. We have a very exhaustive extension development guide there, and as Anja already showed you, from the Java docs.
So I can also send the link to the for the development guide on the follow-up email. Then there is another question by Jose: how to integrate with Oracle IaaS, PaaS, or SaaS?
Pretty much the same. Just exchange the driver. So you could, for example, I showed it again in the IDE. So we had this dependency here to Postgres, and you would need to exchange the database driver here, and of course configure a different database. So if you look here, the database is local, and if you lose an SaaS version, you need to, of course, add in here the JDBC string that the database provides for you.
Okay. All right, and then we have a question by Emmanuel, who asks: are commercial extensions compatible with the open source version of HiveMQ?
So no, they are not. So for the commercial extensions, you would need a professional or an enterprise grade license of HiveMQ. Everything you do and all the open source extensions can be used with the open source platform of HiveMQ, and but the enterprise extension need at least a professional edition.
Okay. So it seems now there is another question coming in: how to decide database connection pool limit, for example, 1,000 client connections to HiveMQ?
Okay, this is really specific, but we can get in brief detail. We have some time left. So let me just show something in code again. So actually, the database extension we just implemented does not follow the newest guidings, the implementation guidelines that we set for our extension. Usually something like a database call is a blocking affair, and we would suggest that you use an asynchronous call here. And pretty much this already limits how much damage you can do with the extension. But to be sure, you usually set the HiveMQ the number of connections to the number of threads in the thread pool that you use to connect to write into the database. So for example, if you would do this in a new thread pool, of course, and the thread pool had 10 threads, then you would open 10 database connections here. Hikari pretty much has its own thread pool already. And HiveMQ provides another thread pool. So this should be you should set up to use this, and it should be fine.
Okay. Then there is an anonymous question, which is, I guess, quickly answered. Do you have a developer license having access to commercial extension, but for development purposes only?
I'm not sure of the question. I guess it's about having a trial license.
No, maybe I can answer. So for developing so there are different ways. You can have the open source SDK or the enterprise SDK, but for this you need specific access that is not given by default, but you have to contact us, and then maybe we start a training and so on, and so this is a kind of consulting service. But if you so normally if you will develop your own extension for professional usage, and you have a professional HiveMQ extension, so you must not you have a professional version for HiveMQ, so you can run always your extensions and also your enterprise extensions in the kind of debug mode, and or not debug, evaluation mode. And this is that you can use this so for developing for 5 hours, and then the extension would be disabled, but you can restart this then. So this is for developing purposes, this might be enough, but it's not for production environment. So this is not the way to work with this.
So to summarize, you have a trial license that comes with the extension, or the commercial extensions. This is like for 5 hours, and then you have to restart it. Or you can talk, of course, to sales. And I'm sure they can come to an arrangement if you need like an evaluation license or something like this.
Yeah.
Okay. Then Mark asks, I'm currently evaluating MQTT server options. Is the HiveMQ Community Edition being widely used in production setups?
Anja?
So this is the Community Edition. This is the question I cannot really answer, because if you're using the Community Edition, we wouldn't know this. So there are a couple of differences in the feature list for the Community Edition and Professional Edition. And yeah, one thing is also the support. And so for this, I don't know if somebody is doing this, maybe, but this is something that we must not know. So you can do this, but then maybe we cannot support this your production environment. So this is from the formal way how this is set up.
So, but yes, we know of people using the Community Edition in production environments.
Yeah.
Usually for smaller case, not mission critical use cases. So something where the enterprise features are not are not necessary.
So if you don't need a cluster, for example, then and only have a small application use case where you need this, then this is completely okay.
Yeah, so we know of people using it, but we don't have like a list or so. Yeah.
And then one last question. What are the differences between commercial and open SDK? Can you develop against both SDKs at the same time?
I can answer. So the difference is that the enterprise SDK has some more functionality, and so functionality that is related to functionality that is also in the professional HiveMQ edition. For example, you can work with the cluster. You can add, for example, your own views on the control center, and we have other ways to for message consumption, that you can do this more in a more faster and way, for example, so this, but you can for sure run a public or open source extension within both HiveMQ editions. So this is for sure possible. And if you, but not an enterprise extension that has code inside that is from the enterprise SDK cannot run together with open source HiveMQ edition. So this is not possible.
Okay, so now there are no open questions left. Georg, Anja, could you switch to our last slide, please?
Sure.
So, okay, thanks for joining us today. We hope you enjoyed this session. We will upload this webinar on our YouTube channel. I sent you the link in the chat. Also, don't forget to subscribe to our newsletter. We will, oh no, there are no unanswered questions. And we will send out the information, everything that you need, and the development guide in the follow-up. And I paste, like you see here, I pasted the links here in the chat. I hope you enjoyed it, and see you next time.
Bye-bye.
Bye.
Bye. Thanks.